We are all seeing these incredibly powerful AI models pop up that can solve problems we once thought were, well, impossible. But behind the scenes, there's this massive, hidden challenge that's been slowing everything down. So let's break down what that is and how some researchers are finally starting to tame the beast. So, what is this secret drag on progress? It's not just about the millions of dollars for giant supercomputers. Now, it's about something much more fundamental. It's about time, specifically wasted time, a huge inefficiency that has been plaguing the development of our most advanced AI. At the heart of this are what are called reasoning LLMs. Now, these are not your average chatbots. These AIs are designed to tackle the really tough stuff, complex programming challenges, multi-step planning, by actually breaking problems down and thinking them through, step by step, kind of like we do. But of course, there's a catch. Building these brilliant models is painfully slow and unbelievably expensive. And it all comes down to one major bottleneck in the whole training process. See, to teach these models how to reason, developers use a method called reinforcement learning. Think of it like this. The AI tries to solve a problem a whole bunch of different ways. It then gets a reward for the best answer, and it uses that feedback to update its own logic. And it does this over and over, thousands and thousands of times. So where does all that time go? You'd think most of it is spent on the actual learning, right? The part where the model gets smarter? Well, take a look at this. It's not even close. A staggering 85% of the time is spent on something else entirely. 85%. Let that sink in. The vast majority of the time, the computer isn't even learning. It's just generating potential answers in a process they call rollout. The actual training, that's just a tiny little 15% sliver. So what does this wild inefficiency actually look like? Okay, imagine you're in a group project. You and a few of your teammates finish your tasks super quickly, but you can't move on. Why? Because you're all stuck waiting for that one person who got the hardest, longest part of the project. You're just sitting there, idle. That is exactly what's happening inside these supercomputers. The fast processors finish their jobs and are just stuck, waiting around for the slowest ones, wasting huge amounts of energy and time. This is where a team from MIT had a really brilliant idea. They looked at all those idle computer processors, all that wasted downtime, and they asked a pretty simple question. Hey, what if we could put that time to good use? And they call their solution taming the long tail, or TLT for short. That long tail is just a fancy term for those few really slow tasks that hold everybody else up. The idea is based on a clever technique where you bring in a helper, a smaller, much faster drafter AI, whose only job is to speed up the big, powerful model. Here's the basic idea of how it works. First, the speedy little drafter model just blasts out a bunch of potential answers. Then the big, powerful model comes in, and instead of generating answers from scratch, it just looks at all the drafter's guesses and verifies them all at once. It's like checking someone's homework instead of doing it all yourself. As you can imagine, this gives the whole thing a massive speed boost. But just using a drafter model isn't the true breakthrough here. The real secret sauce, the key innovation that makes TLT so incredibly effective, is that the whole system is adaptive. I mean, think about it for a second. The main model is learning and changing with every single cycle. So a drafter model that was only trained once at the beginning, it would become outdated and pretty much useless almost immediately. It just wouldn't be on the same page as the new, smarter main model. And that's the difference. The old way of using a static drafter just completely falls apart here. The genius of the TLT method is that the drafter is constantly being retrained, on the fly, making sure it's always perfectly in sync with the latest, greatest version of the main model. And here is the truly brilliant part. Remember all those idle processors just sitting around doing nothing? The very source of the problem? TLT puts them to work. It uses that exact free time to constantly retrain the drafter model. No extra computers, no extra energy. It solves the idle time problem and the stale drafter problem at the exact same time. It's just an absolutely elegant solution. Okay, so the theory is fantastic. But what about the results in the real world? Well, they're just as impressive, leading to some really dramatic performance gains. The results are nothing short of game-changing. When they tested it, the TLT method more than doubled the training speed. We're talking an acceleration of up to 210%. And it did this while completely preserving the accuracy of the final model. No compromises, just pure speed. And, this has experts in the field really taking notice. Song Han, who's an associate professor at MIT and a senior author on this research paper, he praised the method, saying it directly tackles the core computation bottleneck. And for folks in this field, that is a huge stamp of approval. So why does any of this matter to you and me? Well, for one, it means developing the next generation of powerful AI tools will be much faster and cheaper. It means lower energy consumption for an industry that uses a ton of it. This could speed up breakthroughs in everything from forecasting financial trends to building better systems for detecting risks in our power grids. Ultimately, the takeaway here is really clear and incredibly important. By focusing on smarter, more efficient ways to train AI, we're paving the way for a future that's not just faster and cheaper, but a lot more sustainable too. And that leaves us with one final and pretty exciting question to think about. We've just figured out a way to build these powerful reasoning AIs at more than double the speed. So, looking forward, what are the first big, world-changing problems we should ask them to solve?